So today's lessons determine the maximum demand of the consumer main for a block of the 24 homes unit connected across the 3-phase wires. Each unit has a supply with a single phase supply only. So each unit has the following nodes: 11 lighting points, 7 number of the double socket outlets, 3 number of the single socket outlet, 1 number of 15 ampere socket outlet, 1 number of 9x2 kilowatt range, and 1 number of 4x4 storage 4x4 kilowatt storage water heater, and 1 number of the 1000 watt street heater. So those are the loads supplied by the 3-phase supply. There are 24 whole units. So firstly, in the calculation, these 24 whole units are connected by the 3-phase supply. So that each phase, we divide 24 divided by 3, so we got this 8 units. So every phase is supplied by the every 8 unit is supplied by the each phase. So the total unit divided by the each phase is 24 by 3. You got the 8 unit per phase. So in this case, this is a domestic installation. Therefore, we have to utilize the table C1 and the column 4. So that we look at this AS3000 rule, column 4. So because of the here, this is a table C1. So load groups this is column 2 for the single domestic installation, column 2, 3, 4, 5. 3, 4, 5 are for the block living units. So the 2 to 5 are living unit per phase. We have to refer the column 3. 6 to the 20 living unit per phase, we have to refer the column 4. In this problem, every phase is supplying the 8 unit, therefore we have to refer the column 4. So AS3000, table C1, column 4 has to be referred. Then you, based on the load group, so you have to use the columns 1 and the column 4 has to be referred. So this is for the how to utilize the which part of the table C1. So this problem, so the firstly we see the 11 lighting points. So 11 lighting points are each units called as 11 lighting points. Therefore, this is the load group A1 and the column 4. So the load group A1 is here, lighting point is a load group A1. So the column 4. So in how you calculate 5 ampere plus 0.25 ampere per living unit. This is the rule we have to utilize. So the 5 ampere plus 0.25 multiply, they are 8 living units. So 0.25 multiply 8. So this is the we calculated. So the 5 ampere plus 0.25 multiplies are 8 units. You got a 7 ampere. We got it. Then we also find out the socket outlet. So the 7 number of the socket outlet is 7 multiplied 2. This is the 14. Also the 3 number of single socket outlet, so this is 3, and 1000 watt switch heater. 1000 watt switch heater is also the socket outlet. So this is 1 socket outlet. So you add 14 plus 3 plus 1, you got the 18 socket outlets. So 18 socket outlets. So that we see refer the table C1 and column 4 because of the socket outlet load group. So socket outlet load group is here. Socket outlet load group is a B1. So the in this case, this is a rule have to be utilized. So there will be the 10 ampere socket outlet. So 10 ampere socket outlet. So it's a program is given the 10 ampere socket outlet. The 7 number of the socket outlet, 3 number of the single socket outlet. Those are socket outlets are the 1 number of 1000 watt switch heater. So those are socket outlet is not given. So we assume as a 10 ampere socket outlet. So that 10 ampere socket outlets, the rule is given. So the rule in this AS3008 is given the this is socket outlet here, load group B1. 15 ampere plus 3.75 ampere per living unit. So the 15 plus 3.75 multiply, they are 18 units, 18 living units. So the 15 plus 3.75 multiply 8. So this means we calculated. So this is a 15 plus 3.75 multiply 8. You got a 45 ampere. Also, it's also given the 1 number of the 15 ampere socket outlet. The 1 number of 15 ampere socket outlet. This is the 15 ampere socket outlet. Is you see the where the electrical installation include 1 or more 15 ampere socket outlet. So the load group For the 15 ampere socket outlet, load group is B2. In this case, every case we have to take the 10 ampere. So that this is it in this problem. For the 15 ampere socket outlet, we take the 10 ampere. Another thing is a range. That there are two kind of range. One about 9.2 kilowatt range. So this is the load groups are C column 4. So this is we see that electric range here. Electric range, load group is a C. Range could get applied, allow the equipment or the socket outlet rated more than 10 ampere per phase. So in this case, up to 2 to 5 living unit, 15 ampere. For the 6 to 20 or the 21 or more, so 2.8 ampere per living unit. So in this case, every phase got the 8 living units, so that we 2.8 multiply 8. So this is for the electric range. Electric range is a load group C. So we substitute electric range is a load group C, column for the 2.8 multiply 8, you got a 22.2 ampere. Another thing is a 4.4 kilowatt storage water heater. So this is it. We have to refer the storage water heater. So where is a storage water heater? Storage water heater here, load group F. Load group F, in this case, for the 2 to 5 unit, 6 ampere per living unit or 6 to 20 unit, 6 ampere per living unit. So they are living unit, 8 unit per phase. So 6 multiply 8. So this is the way we calculate it. So this is it. 6 multiply 8, 48 ampere. You add everything. So total current will be there. So we add everything 132.2 ampere. So this is for this supply is we need this 132.2 ampere. This supply had to be maximum demand calculation we can calculate it. So this is the way we calculate it like this. Okay, the next problem is that we have to calculate the maximum demand of the single phase consumer main for the 63 unit supply by the 3 phase. So in this case, 15 ampere lighting point, 9 number of the double socket outlet, 5 number of single socket outlet, 1 number of 10 kilowatt range, and 1 number of 5 kilowatt storage water heater, 3 number of 15 ampere socket outlet. So this problem is also similar to the similar approach. We can calculate it. So we follow the same thing. The next one will be we have to determine the maximum demand of the heavier load phase in the domestic electrical installation, comprising the 26 lighting point, 24 number of the 10 ampere single socket outlet, 1 number of 15 ampere socket outlet, 1 number of the 6.6 kilowatts range, and 1 multiply 12.96 kilowatt in the instantaneous water heater, 1 number of the 3.6 kilowatt clothes dryer, and 2 number of 5 kilowatt hot plate, and 1 number of 4 kilowatt air conditioner. And the arrangement for the 3 phase we have to refer this table. So the 3 phase got the red, white, and the blue phase. So red phase got the 5 kilowatt hot plate. We put here 4 kilowatt air con and 4.8 kilowatt instantaneous water heater. This is for the red phase. And white phase include the 15 number of 16 ampere socket outlet, 5 kilowatt the hot plate, 4.8 kilowatt instantaneous water heater, and 3.6 kilowatts clothes dryer. Blue phase include the 26 light point, 9 number of 10 ampere socket outlet, 6.6 kilowatt range, and a 4.8 kilowatt instantaneous water heater. So this is for all the load. We have to arrange to the red, white, and the blue phase that we arrange it. So then based on this white, we have to calculate this table. We have to draw. This table is you can see this the table. Left is a column is a equipment, and then you have to use a load group table, and so this is for the column, and red, white, and the blue. So this is what we calculated. So firstly, we have to calculate the 24 light point. So 24 light point is the rule is here 24 light point. Light point is this is for the lighting unit. So there will be this the rule is we have to utilize a light point. So single living unit is here. This is a single living unit. First 20.3 ampere. Another seconds every set points are 2 ampere. So this is the rule here. So this is the 3 ampere for the first 20 point, 2 ampere for additional 20 point. So this is for single domestic installation. So in this case, we calculate is here we got the first 20 point is 3 ampere. 26 lighting point, so another 6 point. So this is within there's a 20, so you got the 2 ampere. So 3 plus 2, you got the 5 ampere. This is for the blue phase called the 5 ampere. This is for local group A1 and column 2. And then also there you see there are 10 ampere socket outlets. 10 ampere socket, 15 number of the 10 ampere socket outlet are located at the white phase, and 9 number of the 10 ampere socket outlets are located at this blue phase. So we have to refer the socket outlets rule is a B1. The rule is a B1. So in this case, 10 ampere will pass to 20 point, 5 ampere for the additional 20 point. So this is the rule we have to utilize. So these rules are by applying this rule. So first these are 10 number of the 15 number of the 10 ampere socket outlet. Within the 20 point, so we take the 10 ampere. And another thing is a blue phase called the 9 number of 10 ampere socket outlet. So this is within the 20 point, you go to 10 ampere. So this is the rules we take it. So this is the rule we take this as socket outlet. 10 ampere for first to 20 point. So this is 10 ampere we take it. So this is for the socket 15 ampere, 10 ampere socket outlet we calculate it. Now this is range and the hot plate. 5 kilowatt range. So 5 kilowatt range, they are located in the red, white, and the blue phases, the 5 kilowatt range. So red phase, 5 kilowatt, and also the white phase called the 5 kilowatt, and 6.6 kilowatt is located in the blue phase. So the electric range we have to see this low group. Electric range go down here, electric range. Range cooking applied, laundry equipment, socket outlet, rated more than 10 ampere. So in this case, we have to use the 50% of the connected load. This is the rules of 50% of connected load. So we are a part of that rule. So 10 ampere 5 kilowatt range. So we multiply 5 by 10 power 3, and also divided by 240. So you got the ampere multiplied by 0.5. So 10.4 ampere. 10.9 ampere is located in the rapid. Similarly, another 5 kilowatt, 5 multiplied 10 power 3 multiplied 0.5 divided by 240, you got a 10.9 ampere. 6.6 kilowatt, 6.6 multiplied 10 power 3 multiplied 0.5 divided by 240, so 12.7 ampere. So this is for the electric range we calculated. And also that we see that this is for the instantaneous water heater. Instantaneous water heater located on the red phase, white phase, and the blue phase. So the instantaneous water heater, we have to find their low group. The low group is an instantaneous water heater. Low groups are E. So it should be the 33.3% of the connected load. So this is the rule. So we substitute here. So 33.3. So this is for the 4.8 kilowatt. 4.8 minus 10 power 3. 33.3 so multiply 0.33. Divided by 240, you got a 7.5 ampere. So this is for the all red phase, white phase, blue phase. We substitute the 7.5 ampere. And air conditioner is located into the red phase. So we have to find a low group. Low group is a D. So this is the air conditioner. Air conditioner is low group D. Phase space heating or air conditioning equipment. And also more than a 10 ampere. So it is we take the 75% of the connected load. So this is for the air conditioner. We take the 75% of the connected load. So in this case, air conditioner is this is for the air conditioner power is given here. So 9.4 kilowatt air conditioner. Air conditioner 4 kilowatts air conditioner is given. So we substitute the 4 kilowatts air conditioner. 4 by 10 power 3 and 75% of multiplied by 0.75 divided by 240. So then we got a 12.5 ampere. This is located on the red phase. And finally, we find out the clothes dryer. Clothes dryer is located at the blue phase. So clothes dryer is low group C. So this is for that we find a clothes dryer. Low group C because the range cooking apply laundry equipment. So provide laundry equipment. This is the load group C. So it should be the 50% of the connected load. So therefore that we substitute here 50% of connected load 7.5 minus 10 over 3 multiplied by 5 divided by 240. So you got 7.5. So this is the load group C. Then we add the everything on this phase. We add the all current. Then we find out the total current. So total current is a red phase you got a 36.9 and 36.9 and white phase is 35.9 and the blue phase is a 35.2. So in this case the highest red phase is 30.7 and white phase is 35.9, blue phase is 35. So the heavier phase is white phase. So this is the 35.9 ampere. This is the way we calculate that. The next one, we have to calculate determine the maximum demand of the heavier load phase of the block 80 units comprising the following load. So lightings are 80 units, 10 ampere socket outlets are located in the 80 unit, and also the electric range is 17 units are got the electric range, and 2.5 kilowatt or the 10.4 ampere permanent straight heater is every 80 units are all units got this load. And quick recovery help heater. This is for the 80 units. So this is the individual unit got this their load. Every unit got the lighting point. Every unit got a 10 ampere socket outlet, and 17 units got the electric range, and 2.5 kilowatt or 10.4 ampere permanent straight heater. So every unit got it, and quick recovery heater. So every unit got it. And now another thing is a common load. Loading not associated. So this is the common load. The common load is located to there's a common area, for example, stairway, lobby. Those things are common area. So all the common area, their loads are the 90 number of the 60 watt lighting wise, 21 number of the 100 watt lighting wise, and 10 number of the 10 ampere socket outlet, 2 number of 12 kilowatt lift motor, 1 about 5.5 kilowatt 3-phase pump motor, and 1 about 4 kilowatt 3-phase water supply motor. Those are the load allocation. So this is that we got it. Okay, firstly, we have to find out the bins are lighting. So all the 80 units are provided by the 3-phase power supply. So the every phase, how many units? So 80 divided by 3, so you got approximately 27. And also the 10 ampere socket outlet. So how many socket outlet about phase? So the 80 divided by 3, you got a 27. Electric range is total 17, so divided by 3, you got a 6 number. And permanent straight heater got the every 80 unit. So that this is the every phase how many straight heater? 80 divided by 3, you got the 27. Quick recovery heater, every 80 unit for the 3 phase. So the every phase 80 divided by 3, you got a 27. So this is the way we calculate how many unit per phase we are supplying the electric power. So therefore that we have to put the individual load this table. Equipment, and the first column equipment, second column is load group, that column is a column, and now load group are reference column, and now there's a calculation column and the result. So firstly we have to find the 27 unit. 27 unit is load group A1 and column 5 because how many units are this? 27 units. 27 units. So what you find you use a column 5. Here you see the load column 5. No, 21 or more living unit per phase. So this is the column 5. So load group A1 is lighting. So this is lighting point. So the 27 units. So this is the we have to refer this formula. 0.5 ampere per living unit. So the 0.5 multiply 27, you know, 0.5 multiply 27. So we substitute 0.5 multiply 27, you 13.5 ampere, we got it. Also, there's 10 ampere socket outlet. 10 ampere socket outlet is a load group B1. So 10 ampere socket outlet, load group B1. So that in this case, we have to use by 21 pound more, so 50 ampere plus 1.9 ampere per living unit. So the 50 plus 1.9 multiply 27. So this is the way we calculate it. So 50 plus 1.9 by 27, you got the 101.3 ampere. And also the electric range. Electric range is included in the 6 unit. So the electric unit is a 6 unit. So in this case, our electric range is here is a local C. In this case, 6 unit is a tables are column 4. Column 4 6 to 20. So in this case, electric range is a local C. And in this case, only 6 units we call the electric unit range. So in this case, we use as column 4. 2.8 ampere per living unit. So 2.8 multiply 6, we calculate that. So here we substitute 2.6 multiply 6, 6.3 ampere. Street heater. Street heater is a local D. Local D. In this case, 27 unit, every unit got a locals the street heater. So we refer here. So street heater is local D, because of the fixed heating applied. In this case, 27 unit, 75% of the connected load. So 75% of connected load. So we calculated 2.5 kilowatt, 2.5 3, and also the 0.75 and 27. So multiply 27 divided by 240. So you got the 201.6 ampere. And also the water heater, straight water heater is local F. So in this case, we use the column 5. So straight water heater, local F. In this case, 100 ampere plus 0.7, 0.6, 0.8 ampere per living unit. We got 27 living units, so 100 multiply 0.8 multiply 27. So this is the rules we had to use because of the 21 or more is in column 5. So we substitute here. So the 100 plus 0.8 multiply 27. So we got 127.1. So you add everything, you got the 463.8 ampere. You got it. So this is the ways we calculated. Then we have to utilize a column. So in this case, this is for the individual living unit. Now common load you have to refer it. Communal lighting. So communal lighting is a local H because of the local H. So this table here, communal lighting, so local H. So this is the full connected load because of all the lighting points not belong to the individual unit is shown as a communal lighting. So communal lighting is all the common area lighting. So this is every living point. We had to refer 2 to 5 or 6 to 20 or 21 or more. We had to use a full connected load have to utilize. Therefore, the lighting point is you got the local H, so that there will be the total how many numbers. So here you calculated the communal lighting. So the full connected load. Full connected load means we have to refer the full connected load. So this means we have to refer this table here. Lighting point. So the communal lighting 6 to 7, the full load 6 to 7 also you look at. So the incandescent load or the okay. 6 is an incandescent load 60 watt load. So in this case 60 watt and also fluorescent light and the lighting track is given here. So therefore the communal lighting system, we use a 60 kilowatt. So 60 multiply the 40 and also the 21 multiply 100 because of the loads are here. 60 number of the 60 kilowatts, 60 watt lighting point, so 60 multiply 90. Also the 21 number 100 watt lighting point, so 21 multiply 100. So here 90 multiply 90 number of 60 watt lighting point, 21 number of 100 watt lighting point. So 90 multiply 60, this is lighting point, plus 21 multiply 100. So this is also the lighting point. So you add all together, 60 multiply 40, 90 plus 21 multiply 100, and divided by 240, and divided by 3 because of this is belong to the 3 phase. So every phase is we have to divide by 3. And here is a 90 multiplied by 60 plus 21 multiplied by 100 is, this is the power. Power divided by 240, you got the current. And for the 3 phase, every phase is divided by 3. So you got 10.4 ampere. So this is the way lighting point you calculate it. Also the 10 ampere socket outlet. So this is load group J. So 10 ampere socket outlet, load group J. So in this case, every socket outlet we have to apply a load group J so that 50% of the connected load. So this is the 10 ampere socket outlet load group J. So two number of this are how many 10 ampere socket outlet. We have to take the socket outlet calculation. So socket outlet is load group I. So the 2 multiplied by 14 we calculated. 2 ampere per point up to maximum of 15 ampere. So this is a socket outlet not include load group JMM load. So this is what the computer lighting. Computer lighting is we have to utilize it as load group because it does not included in the load groups J. So this is for 2 ampere per point. So 2 ampere point have to be utilized. So the 2 ampere how many point? There will be the 7 socket outlet because we have is given the 20 number of 10 ampere socket outlet for the per 3 phase. So the per phase 20 divided by 3, so you got the 7. So this is a 7 number. So this is 7 number. So this is 7 number of the socket outlet multiplied 2 ampere per phase. So 2 multiplied 7, you got the 40 ampere. So maximum 15 ampere. So if you calculate the result more than 15, you still have to take the 15. But here you got the 14, so you only substitute the 14. So this is the we calculated. Lead motor is not applicable. And then you have to refer the 3-phase motor, 2.5 kilowatt 3-phase motor, and also 4 kilowatt 3-phase motor. So in this case, 3-phase motors are industrial load. You have to refer the table C2 load group D. So this is A3000. We refer the table C2 load group D. So this is we refer the table C2 load group is D. So in this case, this is a residential factory. So residential we refer the column 2, factory you refer the column 3. So this is residential is load group D. So the full load of the highest rated motor plus 50% of the full load of the remainder. So this is the rule. So therefore, in this case, there are 2 motors. One motor got the 2.5 kilowatt, another is 4 kilowatt. So the 4 kilowatt is the highest one. So you have to take the 4 kilowatt. So you take the full load of the 4 kilowatt. And 50% of the remainder, 50% of the remainder is 3.5 kilowatt. So that we have to substitute. So this is the remainder. 5.5 kilowatt is the highest, and 4 kilowatt is the remainder. So the 5.5 kilowatt you have to take full, and remainder is 4 kilowatt. 4 kilowatt 50%. So 5.5 minus 10 power 3 plus 5.5 multiply 4 into 10 power 3 divided by the 3 phase. So you have to divide it by root 3 and subline voltage. Root 3 minus 415. You got the 15.5 ampere. Then you add every day. Then you got the combined load is at 39.7 ampere we calculate. So this is the way we calculate the thing. So then after that we had to combined load calculation we calculated. So that we add the total load. The total individual load is a unit load is 463.8 plus 39.7 combined load, so you 503.5. So ampere we calculated. So this is the way we calculate the maximum demand. So the today's lesson, I have explained you the how to calculate the maximum demand of the domestic installation and also the lighting point. So this is the up to the base of 63 you have to verify it. So this is for the electrical engineer practice. We shall refer this lesson. Then we also find to do the electrical engineer pre-practice. Pre-practice 2. Page number 1. Okay, so when we are working as the electrical engineer or electrical installation, where you find out the approvals permit. When you install the electrical installation, and then we have to seek the permit from the government authority. So the approval include the state government approval, environmental control authorities approval, local council approval, supply authorities approval, water authority approval, with disposal size of prospectus of permit. Those things have to be concerned about. Then we also have to do the environmental impact assessment. Because of your project, how much impact on environment damage can happen need to be assessed. So in this case, we have to concern about the transportation, because sometimes we have to transport the heavy copper metal to be transported. So it need to assess the low capacity of the road, bridge, and where the cargo carrying truck will pass through. In the meantime, we have to adjust the load to be transported to meet the capacity of the load and bridge. This is also important aspect. Then we also have to find out the any copper melting point you are installed. If you are designing, you are making the copper melting point, you are constructing the copper melting point. In this case, we also have to concern about the air pollution. So the installation of the radar need to be installed for the exhaust fan and the tune to be reduced, and the polluted gas to come out to the air. Before the polluted gas come out to the air, we have to control the buildings. Air pollution level need to be tested, and also you have to utilize a starting radius when the air is coming out from the waste gas are coming out. So the starting level or radius, we have to test the air pollution level. Then how those airs air the polluted air will impact on the environment or impact on the resident need to be also measured about. In the meantime, removal process, deposit removal process need to be concerned about. Also, that we have to discharge the water from the your site. In this case, we have to install the appropriate filtering plant to be installed to remove the harmful contaminants of the water exhaustion from the plant. Also important aspect. Noise and vibration need to be concerned about. Noise level of the machineries need to be measured, and a suitable noise absorption enclosure need to be arranged. Those are the environmental impact assessment and the preparation for the your polluted sites. This is also important aspect. Then we also have to find out the water management plan. So when we are installing the wastewater waste management plan, so how to remove the waste also important aspect. The waste are to be stored safely and transported to the suitable storage site, also important aspect. And also the lands are surrounded on erected on the lands adjacent to your site will be contaminated. Therefore, we have to remove the harmful liquid and material from the waste to prevent the contamination of the land, also important aspect. And the heritage and the wildlife concentration also important. You have to make the assessment to prevent the harm the plant cannot make there's a negative impact on them as well. And we also have to utilize the resources. We determine the appropriate energy saving procedure to increase the efficiency of machinery, equipment, and load, also important aspect. Also, you have to increase the use of the nature energy, also important aspect. So this is the way we have to find out the environmental impact assessment. And then here is we are talking about this fluorescent lens connection circuit. So there will be the two fluorescent light supplied by the in supply, so the fluorescent light starter and also bollards their connection. So when the fluorescent lens are taking the electrical current, there will be two voltage. VI is a resistance voltage, VA is an inductor voltage, V is a supply voltage. So that we have to find out the total voltage across the fluorescent lens. So in this case, we have to measure set up the circuit. Then we have to measure the supply voltage, measure the voltage voltage, and then we have to feed in the display also. In the meantime, we also have to supply the supply voltage square equal to resistor voltage square plus inductor voltage square. Therefore, in this case, if you find out the VR, square root of supply voltage square minus VS square. So this is the way we calculate it. And also that we have to determine the inductance of the choke. The VA supply voltage across the choke, HA is an inductive reactance, and I is a current. So by this formula has to be utilized. And then so therefore the HA is a VA by I. So that in this case we got the HL. So this HA divided by 2 by F. Pi is a 3.1416, L is the frequency. Then you can calculate the inductance value. So this is the way we calculate the inductance of the choke. Now we have to install the fire and smoke alarm in the system. Fire and smoke alarm are to be installed across into the AS 2016 cross 4x6. So that you find out the cross 4x6 fire and smoke alarm. AS 2016 cross 4x6. Cross 4x6, we look at the cross 4x6. Why is a cross 4x6? The fire and smoke alarm installation cross 4x6. The smoke alarm installation. National Building Code and the state legislation have requirement for the installation of smoke alarm, including location, number required, and interconnections alarm purpose. So in this case, we have to refer the National Building Code and state legislation to install the smoke alarm. Where the main power smoke alarms are fitted, such alarm may be directly connected to a lighting finance circuit or individual finance circuit. So in this case, those smoke alarm have to connect it to the finance circuit. So this is the rule we have to utilize for the smoke alarm. Smoke alarm installation, that rule has to be utilized. So this is the smoke alarm installation. So the building code of the Australia require the 240 volts smoke alarm. So have to be installed at the primary alarm, and also we also need to connect it to the secondary backup alarm. So lighting finance circuit, individual finance circuit we have to install. And also the building code of Australia require that 240 volt wire smoke alarm to be installed at the primary alarm. Also we install the backup alarm. The heat detection is also important aspect because of the heat data in the smoke alarm. When the fire breaking out, the smoke alarm detect the heat. So in this case, the heat detector is a fire alarm devices designed to respond when the connected thermal energy of fire increases temperature of the heat sensitive equipment. So this is the way how the smoke alarm is utilizing. So that we have to utilize the thermal mass and the conductivity of the element is regulate the rate of the flow of heat into the element. So in this case, the smoke alarm must have the audio capacity 85 decibel. And standard, we have to apply the AS 3000, 3186, and 1993 addition. And also the smoke sensitivity must have the smoke sensitivity range. And the performance under the extreme weather and effect of the temperature need to be concerned about. The heat detectors are that we have to utilize their fixed temperature type and the rated or rise or die. So there are two kinds of heat detector. Now the fire alarm will be the heat detector. Detected die is activated by the heat of flame. Smoke detector die is triggered by the small invisible particle of the smoke, and the photoelectric die is alarm responded to visible smoke particles. So this is the type of the fire alarm. So in this case, we also have to find out the supply textbook section 8 page 2 page 3 of the 24. This is the reference one. So this is for the heat detector alarm construction. So heat detector alarm construction, the response to the heat is a not smoke. In this case, when the temperature is higher, rise to the 75 degrees centigrade, 73 degrees is made a sound. So the reference rule is here the 1603.3 1996 addition, and then so 58 to 88 degrees centigrade. This is operating rate. So that this is included ionizations of protection is included here. Let's test it to the nuisance alarm caused by the contamination such as the dust and insects. Sometimes the smoke, it will be the malfunctioning can happen because nuisance, because of the any contamination or any insect can cause a nuisance tripping. So in this case, without fire, the smoke alarm will be operated can happen like this. So in this case, our fixed operating temperature is a heat detector. We use a 50 to 80 degrees centigrade operate, and rate or rise detector every every minute. When the temperature rise is at 8 degrees centigrade, then rate or rise detector will operate. It is designed to detect the fast blowing fire. So this is the ways we are operating principle of the smoke alarm. So in this case, rate or rise compensation, rate compensation detector is ignore the rush of the one air. Sometimes one air coming out, so that one is a not, one air is a not a fire, so it should be neglect. Contamination is we also utilize the combination of the fixed temperature and the rate or rise heat detector. Two detectors are utilized together. This is for the combination. So electronics thermal detectors are also utilized. So this is include the thermistor or heat sinking sensor device included. So the when the heat are produced, thermistor produce the electric current. So the resistance chain of the thermistor is monitor electronically and operate when the resistance reach the specific value or the certain chain. So this is the ways smoke alarm operates. Here is a connection diagram of the ionization smoke alarm system. So this is for the cathode and anode. When there's an electric heat coming up, so that the electrons will be flowing from the one anode to the anode to cathode, and then because of the electric alarm, the electric current is sent by the electronic circuit, and then alarm will be sound. So they are supplied by the power supply. So there is included a smoke sensing chamber, also the reference chamber, and also radioactive, so they are also included. So it contains a sensing chamber in which enclosed radioactive source and the two electrodes connected to the DC supply. Radioactive source emit the electron and electron charge, and to ionize the air, make the conduction. The conduction causes the electronic circuit to sound the alarm. So this is the operating principle of the smoke alarm. So therefore the smoke alarm is the operation here, audio activity. So this is the thing. So in this case, alarm sensitivity depending on the particle size and the slopes are smoke color. So in this case, sensitivity rate decrease the ionization process. This is the radio electric sensitivity. So radio electric ionization, we can the relative sensitivity. So here is a particle diameter, relative sensitivity, and how the colors are rated. So in this case, the light can be the invisible light, dark, and the black. So the will be the sensitivity rate. So the operation of the dark and the photoelectric, that they are the rated graph you can see on this table. So that when we install a smoke alarm, we install the photos electric type. We install in the lounge, living area, bedroom, and room. You can install ionization. We have to install a hallway, corridor, study room, and home office. Heat detector we have to install at the garage and the ceiling space. Those are the appropriate kind of the places and the appropriate kind of smoke detector has to be installed. Every row of the residential building is the kitchen and the garage. In this case, a combination that take place. In this case, the ionization responds to the solid fire. Paper and the straw is a ionization smoke detector is a responding. Photoelectric is the fume type or lava or fire. In this case, photoelectric subtype is a responding. Therefore, that depending on the kind of fire, appropriate fire detector type will respond to the fire. So in this case, synthetic materials are used for the building. So here is an electrical supply for the smoke detector system. Main is include the service wire and main switch, and then we call the distribution box. In this case, the fire detector is that should be connected to the service wire. So in this case, this is the location of the smoke detector. In this case, ionization smoke detector have to install on the hallway, and photoelectric smoke detector have to install on the balcony barrel. So this is the location. In this case, when you are installing the smoke detector, it should not install the displays because of the here is a roof, so that place and that place. Because from here to 50 millimeter, that distance is that place because of the air is a not circulation. This is a dead air space. Now you cannot install a smoke detector within a dead air space because it cannot sense. Similarly, at the corner from the 300 millimeter range, that range at that place, we cannot install a smoke detector. So in this case, sometimes at the kitchen, if you install it in front of the kitchen, so the kitchen is a normal smokes are the normal smoke. So those smoke detector we will only send the kitchen smoke, and if we send a wrong signal. So this is why we cannot install that kind of smoke detector close to the kitchen. This is also important aspect. So the conductor of the final short circuit is supplying the alarm. So this is about the final short circuit, smoke detector connection, electrical circuit connection. We can connect that. So the other this stage we install about the electrical engineer trade like this. We install the smoke detector system. So I explained about the smoke detector system today. Then we also talking about the electrical engineer workshop like this. Workshop like this 3. So in this case, we are also talking about the electric shock, effect of the electrical circuit. Working with the electricity. So in this case, we have to concern about the psychological effect of the electrical current. When you are working on the near the electrical current, so in this case, what happens is when the power is so high, it can cause the excitation. The excitation and the confusion of molecule can happen because the electrical radiation is too much, so that radiation will excite the electron flow, and then because of the high current flow, mass will be confused. And also passing of the electrical current can also happen, electric burn, and the arrest of the heart, and also injury that can happen. So this is for the important aspect. The touch voltage level appropriately you have to determine. So in this case, there are two kinds of contact. Direct contact is you directly contact to the one on the light wire. This is the direct contact. Indirect contact is for example, this motor is supplied by the electric supply, but the motor is electric current is a leak from the wire to the motor body, the iron body. If you touch the motor body, it is an indirect contact. You do not directly touch the electrical wire, but instead electrical wire is a leak to the motor metallic body, and then you touch in the motor metallic body. This is the indirect contact. Contact with the conductive part, there is not normally light, but it becomes a light under the fault condition because of the insulation failure or some other causes. This is the indirect contact happen. So therefore, we have to be make important aspect of the direct and indirect contact has to be confirmed. It has to be known. So in this case, the effect of this electric current depending on the amount of the short current and nature and direction of electric current and the direction of the through the body, which are electric current from where to where are passing through. This is for the important also aspect. And also we also have to know about the resistance of the body. So the body resistance, amount of the current, and the amount of the energy passing through the body, they determine the effect of the electric current. So the effect of the electric shock, in this case, nerves are immobilization can happen, fibrillation can happen, tissue destruction can happen. Electric shock is accompanied by the blue chairs are piercing and the deadening of the pain, and also the additional contraction of the muscle associated with the path of the current can happen like this. So the electric current or the electric shock, the glands that are able to release a conductive wire. When you are electric tube, you cannot you grip the electrical wire, it's difficult for you to release your electrical wire. So in this case, current will flow in, by this way, person can die. If the person has a touch of light wire without clenching, the muscle past the back and the legs may be contracted harshly, so that the person is unwillingly through the backward. So this is the effect of the electric current can happen. That may also occur as a result of the current flowing through the respiratory controls center of the general nerve system of the person. That is usually caused by the direct interference with the action of the heart. Ventricular fibrillation, electric shock can cause a fear. In this case, a heart attack can also happen. So in this case, electrical current, body resistance is very influenced on the electrical current pass through. The resistance of the body from the hand to hand or the hand to foot is variable, depending on the area of the electrical contact, whether the area is dry or wet, the electric current or body resistance is changing. Body resistance, there's the touch voltage 25 volt is 1750 ohm to 61000 ohm. Dry condition, body resistance is higher, but the sun resistance of the voltage is less than 30 voltage. So this is the things body resistance. So in this case, we have to know about the short current range. In this case, current range is 100 milliampere to the 1000 milliampere. It can cause a defibrillation, tissue burning, fabrication, and cardiac reaction, so it can cause a death. And for the 75 milliampere, it can cause the respirations are stopped, and also the arm will be paralyzed, breathing difficulty, and the Greek current can happen. And up to 50 milliampere are able unbearable pain, and a migraine, and spasm, possession. So those are how the electrical current impact on the body. So the 15 to 17 milliampere Greek current. So in this case, it's extremely difficult to release a conductor held in the hand. So that because of the low conductor electrical current passing through, it can cause the burning of the body. Point of the contact, how the electrical burn is burn the point of the contact, and also the acid burnings, local white skin, and deep reaching to the bone can happen like this. High voltage flash overs are the very extensive burning, and the hot looks and the thing can happen like this. So in this case, we also have to know about the radiation burn. Radiation burn is although you do not touch the electricity by directly, because the electrical current radiation can also burn in the body. Radiation burn is similar to this skin burn from the sensitivity of the earth, burn from the vaporized metal. High voltage allow the for current to flow with the impunity into the body, causing the contact burn passing through the layer of the skin. That's why the tissue below. So the most electric shocks can occur between the 230 volt to the 400 volt, can cause the most electric shock. So that sometimes we how the electric accident happen, because electricians they die by the electrical accident. So the cause of the electrical accidents are the H4 light terminal. If you touch with the H4 light terminal, you can suffer the electrical shock. And also the terminal or the conductor being light under the different conditions or the operation of the equipment, loose or the disconnected leads are becoming alive, and the test equipment conducting the potential closer to electrician, test equipment being the wrong class for the task inadequate for the test work. This is also important aspect. Incorrect poorly made testing equipment the cause of the electrical short circuit, and the inadequate knowledge of the equipment or the cause of fault. equipment located in the hazardous area and walking alone on the light equipment, they are the danger and risk caused to the electrical accident. Therefore, we also have to know about this protective devices. To protect the electric short, we have to utilize a protective devices. In this case, we use a fault fuse and a circuit breaker have to utilize, and also the protection of the fault circuit and the fault condition also important. Also, we have to prevent the melting down of the conductor. It need to be protected and treat all the circuit under the certain hazardous point. For condition, we need to treat all the circuit. Q is designated to the open the circuit when the predetermined AC of the current flow. In this case, fuse should be operated. Rewirable fuses are no longer allowed to be installed in the new installation. All the new installation, we must install a circuit breaker. Separate extra low voltage also important aspect is no more than the 50 volt AC or the 120 volts DC, rebel-free DC. Circuits are designated to remain under the safe voltage level. So this is about how to protect the short circuit protection. In this case, we utilize the residual circuit protection, residual current device. So this is the RCD. So this is the for all the residual current device. So it immediately trip off the electric supply in the event of the current leak to the arcs. Designated to trip with the leakage current of 30 milliampere and operated with the 10 to 50 microseconds. So this is about the residual current device as an operation. So that we have to isolate the electric supply. We have to working on the light circuit. It can cause a danger. It can cause an electric short. Electrical flash over can happen. Short circuits can happen. So the consequence of the electrical accidents are electrocution, severe burn, fall from the height, and the fire and explosion can happen. So therefore, we have to mode the protection. And these are electrical equipment to be worked. We have to utilize isolated by the removing the fuse, switching on the circuit, pressing the emergency stop switch, switch on the control switch, and remove the contact circuit. This is the way how to remove it. Now, when the performing the electrical work and equipment, in this case, you have to utilize a switch off is important, and also remove and isolate and take out procedure. Take out procedure after you disconnect the supply on the main circuit, you have to lock it, and also you have to hand the take out important side signature is important. So therefore we are talking about the correct isolation procedure. Correct isolation procedure is all equipment must be tested for the trust. Test your equipment before and after use. So before you are testing, before and after you have to test your test equipment. You also have to follow the correct isolation procedure. Test voltage tester to confirm the correct operation. You also identify the circuit to be worked on, and the point on the supply is also important. At the swivel, you have to test the circuit breaker. So appropriate take out and lock out need to be utilized. So in this case, take out and lock out procedure is we have to isolate the circuit, and then we have to use the circuit breaker. You have to put this any wedge, you have to remove it, and at the point of the wall, in this case, we have to utilize a appropriate side, and also lock you need to key. So the test, log out, take out, and then you have to test again. So this is the take out and log out procedure. So to protect the electrical circuits causing the fault, we have to utilize the hardening system. All the external metals are casing all the electrical equipment, cable, conductor must be added to prevent the electrical metal rising to the dangerous voltage level. So this is for the how the electrical current is conducted. So this is neutral, this is up. So the gateway meter, this is main switch and connected to circuit breaker, electrical equipment. So we are in neutral link, this is unlink. So the all equipment connected to the conductor unlink. So neutral is connected, and then from the unlink connected to main electrode. So this is the way. This is the MES hardening system. That kind of the protection system have to be utilized. So in this case, we also have to utilize the electrical equipment to be work must be isolated. So you have to removing the fuse, switching on the circuit breaker, pressing the emergency stop switch, switch off the control switch, remove the contact of the point of connection. So when the performer of electrical work on the supply equipment, in this case, you have to switch on, remove the isolate, take on a log out must be utilized. So this is the ways are take on and log out being utilized. Okay, so here's our electrical trade. We explain about the electrical condenser circuit breaker and fault protection and working with the electricity. We explain about. Then we are talking about the diploma, advanced diploma. So we do the thing. Austrian connected, and also the electrical electronic associate. Then we find the diploma, advanced diploma in electrical engineering. Electrical diploma 2022. Click it. Then go down. We're talking about the video lesson. We do video lesson, we click it. Then we find out the lesson. The lessons are last week we have already finished the G48. So today's we do the advanced engineering mathematics. So the advanced engineering mathematics we have to use the link is a video lesson, page 26 to 50. So this is the link here. The notes video lesson. Page 26 to 50. So just open. So video lesson you can get from this site, highlightcomputer.com/video lesson.pdf. Here, page 26 to 50, you have to read it. So page 26. So this is for the 26. This is the note, written notes. Based on the written notes, I give you the video lesson. The video lessons are based on those written notes. Page 26 to 50. So this is for the written notes. So you have to download and you have to read this page 26 to 50. Then you also view the video lesson. Lesson 1 4 year.
So we want to find the Fourier term, Fourier series for the this waveform, A waveform the square waveform. Minus pi by 2 to plus pi by 2, the Fourier value is 100. Pi by 2 to 3 pi by 2 is minus 100. And 3 pi by 2 to 2 pi, it will be 100. So this is an even symmetry because this is a y is A. So this part and this part, you can fold. So this part is right part and left part, you can fold together. So this is an even symmetry. Even symmetry, there is a Vn is 0, only the An have to be calculated. So the An can be calculated. An formula is 1 by pi. So in this case, I going to integrate 0 to 2 pi. So An formula is 1 by pi, 0 to 2 pi, dt cos n theta into d theta. So this is the equation for the An. So from 0 to 2 pi, you have to integrate. But this one is a square wave. This quantity and the pi by 2 and 3 pi by 2. So then, when you integrate the 0 to 2 pi, you integrate from 0 to pi by 2, and then pi by 2 to 3 pi by 2, and 3 pi by 2 to 2 pi. So when you integrate, so this is the general formula 1 by pi here, 0 to pi by 2. This is the 100 cos n theta into d theta. pi by 2 to 3 pi by 2. So this is value is minus 100 cos n theta d theta. 3 pi by 2 to 2 pi. So this is for the 100 cos n theta d theta. So this is what we call equation. So we want to integrate. So this n theta, so this must be also be the n theta. So that we can integrate. So that we multiply with this n divided by n. And similarly here, we multiply n divided by n. Here also multiply with n divided by n. So here we put 100. 100 you can take out 100 by pi n. So integrate it as 0 to pi by 2 cos n theta d n theta minus pi by 2 to 3 pi by 2 cos n theta d n theta plus 3 pi by 2 to 2 pi cos n theta into d n theta. So the cos integrate, we call the sine. Sine n theta, so limit is 0 to pi by 2. And similarly here, sine n theta, lower limit pi by 2, upper limit 3 pi by 2. And this one, sine n theta, lower limit 3 pi by 2, upper limit is 2 pi. After that, you substitute. You substitute the sine n pi by 2, so 0 must substitute sine 0 will be the 0. Here is minus sine 3 pi by 2 substitute, so 3 pi n by 2. Lower limit substitute, so minus sine n pi by 2. And here you also substitute as upper limit. So this is called as sine 2 pi n. Lower limit substitute sine 3 pi n by 2. So by solving this one, what you go is 200 by pi n, sine n by 2 minus sine 3 pi n by 2. So the n1, so if substitute n equal to 1, you got the a1 value. So in the place of the 1 you substitute. So this is the sine pi by 2 minus sine 3 pi by 2. Sine pi by 2 is sine 90, sine 3 pi by 2 is sine 270. So that you use a calculator, so that finally you got it as 200 by pi. So a2 will be 0. When you got it n equal to 2, you substitute here, so a2 can become a 0. When you substitute n3, a3 is a minus 400 by 3 pi. And therefore that you got a1, a3 value, so you write down the equation, a0 plus a1 cos theta plus a2 cos 2 theta plus a3 cos 3 theta. a0 is 0. a1 value is 400 by pi cos theta. a2 0, a3 value is minus 400 by 3 pi cos 3 theta. So this is for, we get the Fourier series. So the waveform, we use the Z formula, and we analyze the waveform as an even symmetry, only the AM value to calculate. So you substitute the AM formula here, integrate, and we got the equation.
Video 2, differential equation.
Okay, we want to integrate the ACH divided by 1 plus a square plus y dy divided by 4 plus y square equal to 0. So we want to integrate. So that this is the dh. So after the d, there must be the 1 plus a square, so that we can integrate. And similarly dy. So this after the d, there must be the 4 plus y square, so that we can integrate. So that this dh must be the d into 1 plus a square. This dy must be the d into 4 plus y square. So first we find the d into 1 plus a square. So d 1 plus a square is equal to d1 plus dh square. So dh square is differentiate. dy equals to 0. So dh square is 2h into dh. So the dh square is equal to 2h, so that h is equal to half into d into 1 plus a square. Similarly, d into 4 plus y square. So that will be the d4 plus dy square. So d4 differentiate is 0, your cosine differentiate is 0. dy square will become the 2 by dy. So d into 4 plus y square is 2 by dy. Therefore, the y dy is equal to d into 4 plus y square divided by 2. So this integration, h is by 1 plus a square plus y divided by 4 plus y square. In the place of the h, you can substitute the half into d 1 plus a square. In the place of the y dy, you can substitute y dy equal to d into 4 plus y square by 2. So that means the integration half into d into 1 plus a square divided by 1 plus a square. integration half into d into 4 plus y square divided by 4 plus y square equal to 0. So in this case, that you see a 1 by u into u is equal to a ln u. This is the equation. 1 by u, du is equal to ln u. So here is this d and this are the same. 1 by a square here, 1 by a square here. So there will be half into ln 1 by a square. Here is a 4 plus y square. This is a d into 4 plus y square. So there will be half into ln 4 plus y square. So the final answer will be half into ln 1 by a square plus half into ln 4 plus y square equal to 0. So those are the solutions of the ordinary differential equation. So regarding this problem, you have to do an exercise. So if you know advanced diploma electrical solution.com. And so answer the E26. So number 3 of ordinary.
The gamma and beta function.
So this is the integration 0 to 1, 8 over 4, 1 minus 8 over 3 d8. So we compare with integration 0 to 1, 8 over n minus 1, 1 minus 8 over n minus 1 d8. So in this case, our m is equal to n minus 1 is 4, so the m is equal to 1 plus 4 is 5. N minus 1 is 3, so n is equal to 1 plus 3 into 4. So we write down the equation, then we get gamma n divided by gamma n plus n. Then we substitute n value. Gamma 5, gamma 4, gamma 5 plus 4. So the gamma 5 will be the gamma 4 plus 1, gamma 4 is the gamma 3 plus 1, gamma 5 plus 4 is the gamma 8 plus 1. So gamma 4 plus 1 is 4 factorial, gamma 3 plus 1 is a 3 factorial, gamma 8 plus 1 is 8 factorial. So there we got the function 4 factorial 4 3 2 1, 3 factorial is 3 2 1, 8 factorial is 8 7 6 5 4 3 2 1. So by solving this one, you got the 1 by 256. And another equations are integration 0 to pi by 2, sine power 2n minus 1 theta, cos power 2n minus 1 theta is equal to half into theta mm. So in this case, you can write out half into gamma n divided by gamma n plus n. So we solve this equation. Integration 0 to pi by 2, sine power 6 theta d theta. So we compare with integration 0 to pi by 2, sine power 2n minus 1 theta, cos power 2n minus 1 theta d theta. So the 2n minus 1 is equal to 6, so the n is 7 by 2. There is a no cos function. Therefore, the 2n minus 1 is equal to 0, so the n is equal to 5. So we substitute beta 7 by 2 into half, so half into beta, gamma 7 by 2, gamma half divided by gamma 7 by 2 into plus half. So gamma 7 by 2 is a 1 plus gamma 5 by 2, gamma 5 is the square root of pi. Gamma 8, we got gamma 7 by 2 plus gamma 1 by 2, they will the gamma 8 by 2. Gamma 8 by 2 will be gamma 4. Gamma 4 will be then gamma 4 is equal to gamma 3 plus 1. So this is the 3 factorial. Also this one 3 factorial. So 3 factorial. Gamma 3 plus 1. So gamma 3 factorial is 3 factorial. So the gamma 5 by 2 can also be expand. So the gamma 5 by 2 is gamma 1 into 1 plus 3 by 2. So this is the 3 by 2 gamma 3 by 2. Gamma 3 by 2 expand also gamma half plus 1, so that this is the gamma half. So that by solving this one, the final answer will be the 5 by divided by 32.
So now we're talking about the beta and gamma function. We continue.
So today's topic is the gamma, beta, and the other special functions. The gamma functions are beta function. Between the two limits, minus 4 and minus 3, then we function go down and go back to the maximum. They say go down minima and rise back to the maximum. Go down and rise back to the maximum. So that kind of function is a gamma function. So the given for the gamma function is a n value 1 to 2. From the 1, so gamma function is a 1. 1/1 so 0.95, 1/8 is 0.8534, 8435, 1/9 will be 0.96182, so it's 1. So you see the thing, function go down and then go sustain. So that we can calculate the gamma function. The formula is the gamma function of n is equal to integration 0 to infinity, h power n minus 1, e power minus h dx. So the gamma n plus 1 is equal to n into gamma n. So gamma n plus 1 is equal to n factorial. So this is the equation. So the gamma half is equal to square root of pi. So the n factorial means the 4 factorial is 4 multiplied 3 multiplied 2 multiplied 1. 3 factorial is 3 multiplied 2 multiplied 1. 2 factorial is 2 multiplied 1 and 1 factorial is 1. So this is for the gamma function equation. Mostly we utilize the gamma function n plus 1 is n into gamma n. So gamma n plus 1 is n factorial. So this is the way we calculate the gamma function. Okay, so now that we solved this problem, the gamma 6 divided by 2 gamma 3. So gamma 6 you write down, gamma is 5 plus 1. Gamma 5 plus 1 is 5 factorial. And so gamma 3 is 2 plus 1. 3 is 2 plus 1. So gamma 2 plus 1 is 2 factorial. So numerator is 5 factorial. Denominator is 2 multiplied 2 factorial. So 5 factorial we expand. So 5 multiplied 4 multiplied 3 multiplied 2 multiplied 1. 2 factorial is 2 multiplied 1. So we solve this one, we call it 30. This is the first problem. The second problem is gamma 5 by 2. And numerator, denominator is gamma half. So gamma 5 by 2 is 1 plus 3 by 2. And gamma is square root of 5. So in this case, 1 plus 3 by 2, we use this equation here. Gamma n plus 1 is equal to n into n factorial. So this is the gamma 1 plus 3 by 2 will be there. 3 by 2, gamma 3 by 2. So we call like this. So the gamma 3 by 2 we have to expand. 3 by 2 is 1 plus half. So 1 plus half will be the half coming out, half into gamma half. So this is a 3 by 2 multiply half into gamma half. Gamma half is a square root of 5. So the 3 by 2 into half multiply is a 3 by 4. And numerator root by, denominator root by. We cancel so the function will be the 3 by 4. And this is for the gamma function. Beta function equation is the beta n is equal to integration 0 to 1 h power n minus 1 and 1 minus h power n minus 1. And beta n can also be written. This becomes the gamma function of n multiplying gamma function of n divided by gamma function of n plus n. So these formulas are utilized to calculate the beta function.
And then beta analysis.
So today let's take the beta analysis. So this is the beta A. If you put the negative sign, beta will be reversed. So A and B you add. So this is A here and B. A arrowhead is combined with the B arrow A. So the A plus B beta will be this direction. So A plus B is equal to B plus A. This is the law of beta algebra. A plus B plus C is equal to A plus B plus C. N plus N into A is equal to MA plus NA. So the AD is A1I plus A2J plus A3J. So the magnitude is equal to square root of A1 square plus A2 square plus A3 square. Dot product A is equal to A1I plus A2J plus A3J. B is equal to B1I plus B2J plus B3J. So A dot B is equal to A1B1 plus A2B2 plus A3B3. Cross product is a beta product. So in this case, IJJ here determinant. So the entries are A1, A2, A3, B1, B2, and B3. So when you are considering as I, so that all the row including the I and the column including the I are negative. So the only left is A2, A3, B2, B3. So you write down A2, A3, B2, B3. So I is a positive. The J is a negative. All these are column including J and the row including J are negative. So that will be the entry will be the A1, B1, A3, B3. For the K, positive K. So the column including K and the row including K are negative. So the entry will be the A1, A2, A1, B2. So the multiply this direction the positive, that direction the negative. And therefore the I multiply A2, B3 minus B2, A3. Minus J, this direction positive, A1, B3. This direction multiplication negative, so minus B1, A3. Plus K, this direction multiplication, A1, B2. This direction So the negative, so B1, A2. So this is the thing we call this cross product. So we saw that the program A is equal to I plus J, B is equal to 2I minus 3J plus K, C is equal to 4J minus 3J. Then to find A plus B in the bracket, A multiplying B, cross product, and the whole thing is cross product minus C.
Then harmonic function. So that this is the things today lesson. I explain you about the electrical engineer practice, electrical engineer trade practice, electrical engineer workshop practice, and also advanced diploma.